Hello, dear friends. I welcome you all to the video lecture series on Python application programming prescribed by uh, VTU. In this video, I'll be discussing on classes and objects from module 4. So far, we have used functions in our previous modules. The functions are used in order to organize the codes, whereas built-in types like we had integer, float, tuple, dictionary, and so on. It was used in order to organize the data. Python deals with the object-oriented concepts or programming concepts where an user can have his own defined types which organizes both codes as well as data. One can have his own programmer defined type referred to as classes in Python. Here I have a new class which I can define. It is defined using the keyword called class, followed by its class name, colon, just like your function, how you used to define your function by calling the keyword def space function name, colon, followed by the body of the function. Here I have class name, colon, followed by the body of the class, which may include an initializer, any number of attributes, or any number of functions. Here, if I am using defining a function outside the class, I call it as a function, user-defined function. Say if I use a function inside the class, I will call it as a method. So this method is a function if it has been called outside. Here it's a method, and method will have some statements, some specific task which should be performed. Let us see an example of a programmer defined type, which is also called a class. I create a class called point, which represents a point in a 2D space. This is my comment. This is a body which consists of a document string that explains what this class belongs to or what this class is going to do. And I can define a variable and methods inside a class definition. I can have initializer, I can have attributes, I can have methods. Say if I want to define a variable, I can define a variable like x is equal to 2. I can have a document string just like what I have used. It represents a class, something like this. And I can have an attributes, I can have an initializer. This I have an initialized a variable called x is equal to 2. I can have a method. Again, a method, my method, say for example, I can have my method, okay, and I can have statements here. If you observe, I have defined a method, I defined a function in fact, and it is called as a method inside the class. So these are the possible body of the class. Here, let me retain a document string which defines what that class belongs to or what is the class. Now, defining a class name point creates a class object. See, if I call by the class name, I have given it as a point. So if I call it outside the class, so this will be a main class with a point. So this is an object now. If I assign a class to any variable, so it creates an object. So now I assign a class called point to a variable called blank. So this returns the value from the class to a point object. So this is a reference value to a point object which we assign to a variable called blank. So this is called as creating an instance of a point, creating an instance of a class. Now, the process to create an instance, you call it as an instantiation. And the object is an instance of the class. See, this is an instance of the class. I call it as an object, I call it as an instance, both. So object and instances are interchangeable. So this can be called as any ways, like it can be an object or it can be an instance. And process instantiation. Now I have created an instance or an object called blank. Now, can I have attributes? Yeah, you can create an attribute. You can assign value to an instance using a dot notation. Suppose I want to create an attribute called X inside a class point. So now point is referred to as an object called blank. So now I would call it as blank dot X as an attribute where I have assigned a value called 3.0, and I have another variable blank dot Y. Why? Because I can have 2 points, 2 values as a point. In order to locate a point in a space, so you should have X and Y coordinates. So X, I will represent it as a point. So that point is given as 3.0, blank dot Y, again 4. The variable blank refers to a point object and X refer to its attributes. And here point has got 2 attributes, blank dot X and blank dot Y. It's just like X comma Y I have. So now you can read the value of an attribute using the same syntax like blank dot X. So I can, 1 second, I have, since I have not executed, I have not created an object, so it would give me and blank is not defined. So now the blank is defined. Yeah, the blank is defined. Now you'll get blank dot X. What is the value of blank dot X now? Blank refers to an object, which refers to a class point, and dot X refers to an attribute, which has got the value 3.0. Now I can use dot notation as part of any expression. See, I have used this dot notations as a part of this expression. Here percentile G is a float type format, and I can print those values using this notation. So this becomes a part of my expression. See, the values of blank dot X and blank dot Y is assigned to used in this expression, and it is printed. I can use dot notation as part of an expression. This is an example 2 where I have imported math module, and here I have used blank dot X to the power of 2 plus blank dot X to the power of 2. I'm just trying to calculate the squared distance between these 2 points X and Y by using the expression math dot square root and passing the input arguments as object attributes. So I can print this. I have a distance between 3 and 4 as 5. It's an Euclidean distance. Now you can also pass an instance as an argument in the usual way to any function. I have defined a function called print underscore point of P. See, this P represents to a class now. I shall call it outside. So now I have a function called print underscore point, and which takes an input argument P, which is an instance here. Class point, I have defined a class called point. It represents two-dimensional space. Now I have blank is equal to point. I have created an instance or an object called blank. I have created an attributes called X and Y with respect to this object, blank dot X, blank dot Y. Now I can use blank. See here, the blank is nothing but a class or an instance of a class called object with 2 attributes being given as an instance. Instance is given as an input argument to print underscore point, which is a function. So now if I run this program, this is an instance or an object which is created, attributes has been created. Now I pass this instance, and you know, to pass it as blank dot X, you just simply say blank, and blank is considered as P here, which is an instance, and P has got 2 attributes, P dot X, P dot Y inside this function, and the function is executed by printing the statements 3, 4. So now I can write a function called distance underscore between underscore points that takes 2 points as arguments and return the distance between them using a class and objects. So here I have imported math. Why? Because I have a function called distance underscore between points where distance is given as an equation math dot square root. I am going to use the method called dot square root in math module with blank dot X, blank dot Y. These are the 2 input arguments from the function, and now a class has been created to represent the point objects. Now blank is equal to point. I create an object. I assign two attributes to this class as 3 and 4. And now I simply pass this instance as a input argument to this function, and I shall generate the output as 5.0. Now you can observe here, I've simply represented as P, but I have not used this P.x. Otherwise, I can use blank also. I can use P also, that is also fine. If you are just in order to avoid confusion, I can use the attributes from same variable. I can generate the same output, that is distance between 2 points x and y is 5. But the problem is, suppose I have many classes. Say I have a class called point, I have a class called rectangle, I have a class called square, I have a class called pentagon, hexagon, and so on. It becomes obvious what are the attributes of an object should be. And if other times, but other times you have to make decisions. For example, if you have a class to represent rectangle, what attributes you have created to specify the rectangle or the location or the size of a rectangle. So now here I can have two possibilities that you could specify one corner of the rectangle and the width and the height. You could also specify two opposing corners and you can create a rectangle. But here I want to specify what are the attributes. See here, the attributes to the class point is a 2D space. I can have two attributes. I'll just mention it here. I can have two attributes to create a points. Okay, I can have two attributes, like I'll mention it here as x comma y. But here in rectangle, I can have attributes with respect to a width, a height, a corner. Again, identify, you can analyze the corner is a point with x comma y generally. With x comma y. If you want to specify a corner at the origin, it would be the value of x comma y would be 0 comma 0 at the origin. So now you can represent a rectangle with an attribute width, an attribute height, with an attribute corner, which either represents a point xy. Again, it can be a class already been created with a point. Let us just take this example. I have created a class called point, class called rectangle. Now, I have created an instance called box, which is equal to rectangle class. So now box.width, box.height. I have created two attributes with respect to width and with respect to height to a box. What is box? Box is an instance of a rectangle. Is it okay? Now, but I have another attribute called box.corner. So I can have a box.corner. Again, I create an instance of an object with an attribute called point. Okay, here I'm going to assign, I'm going to create an instance to an attribute with box.corner, or I call it, I'll assign a class. Here I have created an attribute with an instance. Now, if I want a variable or an attribute to this point, to this object, now box.corner.x, this box.corner referred to a class called point, and box.corner.x refers to an attribute which belongs to this class. So here box.corner.x means it goes to the object box, refers to and select to an attribute called corner, and inside this corner I have an attribute named x. So this entire box.corner becomes another object, and I have dot x, it is 0, box.corner.y, another attribute to the corner box, box.corner, it is again 0. So this creates an attributes to the rectangle of width, of height, and corner. Again, I have an attribute inside this object dot x and dot y. Now let us just try to see an example. I have created a function which finds the center of the rectangle. So now I have some values given to width, values given to height, like 100 and 200, and the origin is 0, 0. Now I would call a function, and I would call an instance inside this function p is equal to point, because the values, the returned values of this function is a point which finds the center of the rectangle. So now I have this p dot x and p dot y, which are two attributes of this class point. Okay, now I have an expression called p dot x, which is an attribute, which is equal to rectangular dot corner dot x, that is corner dot x is 0 plus rectangular dot width divided by 2, that is 100 by 2 is 50. Excuse me. P dot y, which is equal to rect dot corner dot y, that is 0 again. Why? Because I am trying to find the centroid of the rectangle. So now rectangle rect dot corner dot y plus rect dot height by 2. This is an expression which calculates p dot x, p dot y. So in general, it returns me the value of two values, that is with respect to x and y. So this p is an object now. So if I run this program, I shall, and outside the program, outside the function, I have created an object. Center is equal to find underscore center box. See, this is very important. What is this box? Box is an instance, and box is an instance with rectangle which has got three attributes. In these three attributes, I have width, height, and corner, which is again an object with attributes x and y. Be very careful. So box here, it is an instance which I have given it as an input argument to the function called find underscore center, and I'm going to use print underscore point function, which I have already created here. I've already created here print underscore point. I can use the same function if it's already been compiled, been run on this Jupyter notebook. It can be used a number of times in any of the cells. So I use I can use this print underscore point anywhere across the cell, any cells. If I run this program, yeah, you can see I have found the center of 50, 100 of the rectangle with the width 100, 200, height, and with the corners been specified at the origin 0, 0. Yeah, this is the complete program. I have defined the class point, class rectangle. I create an attribute instance of rectangle or an object, both are interchangeable. Box, I have attributes width, height, and corner. The corner was an attribute which was an object again with respect to a point, and this object has got two attributes x and y, 0, 0. Now this box consists of width, height, attributes, corner attribute. Again, the corner is an instance with two attributes, and I have created you have a function called find underscore center, which takes an input argument as rect. I can call p is equal to point p dot x. It's the same function I have written. Same function. Yeah. And here outside the function, I have another function which prints the center is and so and so. And I have center is equal to find underscore center box. See here, I have declared the attributes and created an object called box, and I have simply passed this instance as an input argument to find underscore center, and I simply print this value center, print underscore point. So it gives me the same answer. Yeah, now what is this box? This box is an object. Is objects mutable? Yeah, it is mutable. You can change the values of this object. How can you change the value? You can change the state of an object by making an assignment to one of its attribute. Suppose box is a rectangle, box dot width is a width, box dot height is an attribute, box dot corner with two values here. I can change by calling its value. See, box dot width assigned to a value called 100. I can change the value of this box dot width by creating an expression box dot width is equal to box dot width plus 50. Direct assignment to an attribute. Direct assignment to an attribute. You can change the value of the attribute. So now it is getting changed to, earlier it was 50. It was 100 and 200. Now it got changed to 150. Why? Because I have added 50 units to box dot width, and I have added 100 units to box dot height. So it became 150, 300. You can also write a function that modifies objects. I have written a small function called grow underscore rectangle, which takes input as the object rect, and d width and d height is the values or units which user is intended to increase the width as well as height. So d width and d height are just like 50 and 100, but rect is box, something like box object, which has got width and height. And I use rect. Rect is equal to rect dot width. Rect dot height is nothing but box dot width and box dot height plus equal to d width and d height. D width and d height are the two input arguments which has been received by the user outside the function. Now I have box. What is box now? The new value of box is an object with the width attribute 150 and the height attribute as 300. Now this box is an instance which is considered as rect inside this function, and box anything dot width, this is the variable or an attribute which you have created. So dot width refers to dot box dot width and dot height refers to box dot height. So this is very important. Dot width and dot height are the attributes or the variables. Plus equal to, it increments with the value which creates, which modifies the existing object by 50, that is d width, and by 100, that is d height, plus equal to d width plus equal to d height. So now the new value of rect dot width and rect dot height, which are true attributes, are box dot width and box dot height outside this function. So it is 150 plus 50, that is 200, 300 plus 100, it is 400. See, I have changed the values of the attributes. So objects are mutable. Yeah, I've written this complete program here. You can go through this program: class point, class rectangle, box, grow rectangle, box dot width. I can try to assign, I can change or modify the objects by directly assigning some values, or I can assign and pass the instance as an input argument and pass the values which need to be the values of scale which need to be changed, and use this function and create an output or generate an output. So this was the rectangle before. Just this is the rectangle before here. I have just simply added 50 and 100 units to the existing width and height of the rectangle, and I shall consider the same in input. This is again the changed values of the attribute. I shall consider the same input here, modified modified values of the object, and again 50 and 100 increments has been made to this. Just go through this program very carefully, line by line, and of course after this video I'll be sharing this video content on your Edmodo along with the program. You can just try to change the values, go line by line, try to compile it, execute, and modify the values, and run a number of iterations to understand this concept. Copying here, sometimes we have created an aliased object, say x is equal to 2, x is equal to 4. So what is the value of x now? X is equal to 4. Aliasing can make a program difficult to do because changes made in one place might have some unexpected effects in another place. So it is very hard or very difficult to keep track of all the variables that I have used to refer to a given object. So what I do, copying an object is an alternative to an aliasing. We have a method called copy, and inside a copy we have a module called copy, which copies the function, which copies the attributes values to another object. Suppose I have a class called point. I have p1, which is an object with two attributes, p1.x, p1.y, and this is a function which prints the attribute values. So now if I say, so p1 is a point now, p1 is a point and which has got two attributes. So it prints the value also, fine. Now what is p2? P2 I am going to import copy. The copy is a module, And inside this module, I have so many methods. One such method is dot copy. So copy P1. So now this is an aliased object now. Remember, P1 and P2 contains the same data as P1.x, P1.y, two attributes, and whatever values been assigned to these attributes. Fine. So now I alias this P1 and P2. Now what is P1 and P2? P1 and P2 are two different objects. Remember, printer underscore point P1, I have 3,4. Printer underscore point P2, I have 3,4. Both are same. Both have got same attributes, same values. But is P1 and P2 same with respect to object? No, it is false. Why? Because P1 is a different object and P2 is a different object. Remember, are the values of P1 and P2 same? You might be expecting true, but no, it is false. Why? Because P1 and P2 are again different objects. So this equal to operator, that is a logical equal to operator, is also a false, though it has referred to the same value, but the objects are different. Is P1.x, P2.x same? Yeah, it is true. Why? Because the values of P1.x, that is 3, P2.x, that is 3, it was true, right? So note, the operator indicates that P1 and P2 are not the same object, what we expected, but you might have expected to be true when you use equal to operator, but this is false because this point contain the same data, but not the same object. In that case, you'll be disappointed to learn, okay, fine. That's because for programmer defined types, Python does not know what should be considered equivalent. So if you use copy.copy to duplicate a rectangle, you'll find that it copies the rectangle object, but not the embedded point. Let us take an example. Class rectangle. Here I have a class called rectangle, class called point, just what you have studied just a few moments ago. Now I have created an object box rectangle, attributes width, height, corner. Again, corner is an object with respect to a point which has got two attributes, x and y. Now I say box2 is equal to, I simply use copy.copy box. So now what is box2 and box? Box2 is box. False. Why? Because these are two different objects. So sorry, I have to compile this. So now if I say box2 is box, now it would say false. Yeah, it's false. Box2.corner is box.corner. That means the attributes of box with respect to the corner, the attributes of box2 with respect to the corner. This is true. Why? Because it copies the rectangle, but not the embedded object. This is very important. The attributes can be copied as it can be created as different objects, but here embedded point is not an object. You understand? Attributes here. Suppose if I say box2 dot width, box dot width. Just an example. It says true. That means the embedded objects or embedded attributes has not been created with different objects. Remember, so any changes been made with respect to box2.width is reflected in box.width. Why? Because both are referring to the same value. So, and this is not what we are expecting when we create an aliasing. It should be treated different. So what we need to do, I use, since this is true, since I have not created two different objects with the embedded point or with the embedded attributes, so I use deep copy. So it copies not only the object, but also the object it referred to and the object they refer to, and so on. Remember, so now I create another instance called box3, which is equal to copy dot deep copy. I use, since I have already imported copy here, I need not to import it again. So box3 is equal to copy dot deep copy. This is another method inside this module called copy box. So I use the same box here. I shall give it as an input argument, deep copy box3. Now I shall see box3 is box. It says false. Now what was your question? It was earlier box2 is box corner. It said true. Now Since I had made box 3 as a deep copy, now let me verify with box.corner, that is box 3.corner is box 3. Now it says false. Why? Because it has two different objects. Box 3 and box are completely a separate object. If you want to verify box 2 and box as a different object, it says false. Okay, and box 2.corner as box.corner, it says true, but box 3.corner with box.corner, it says false. Again, you can verify with box 3.corner with box 2.corner. Again, it says false. Why? Because this box 3 is a completely a different object. So you use deep copy with respect to what do you say, with respect to in order to create a different objects. So this was all about classes and objects in this video. So in next video, in part 2, module 4 part 2 video, we are going to discuss about classes and methods, classes and functions. How we are going to create a functions and classes, try to integrate these two. We are going to create classes and methods, and going to call these functions inside the classes in order to make it as a method, and just see like how it behaves. Can we create a different methods and how to call those methods outside the class, and in the next coming video. I hope you have enjoyed this video. If you have watched this video on Edmodo, kindly make a like on the post or to the video, and the quizzes and assignments will be given at the end of the session. So kindly attend the quiz based on this video, as well as assignments based on this video, and submit it before the due date. And it will be considered for the further evaluation of this course towards your final attainment marks. I hope you have enjoyed this video, and all the other videos which has been posted in your Edmodo. And thank you for watching this video. Take care, stay home, stay safe. All the best.